Hello and welcome. I'm Andreas. I work as a trainer and consultant primarily for C++. And I'm also the creator of C++ Insights. And this is also the tool I like to talk about in this series. In this episode, I will explain what C++ Insights is and give you a little introduction in where you can find it and how you can easily use it. So in today's episode, I would say we touch move semantics again because it came in with move semantics. We are looking at R value or forwarding references to be more precise today. Say we have a function template fun like it's shown in line number 2. There we take a tref. Why? Because everybody tells you to do perfect forwarding and tref, you don't have to care whether it's an L or an R value, it works in any case. Okay, so it's also simple and it appears to be a good solution because, well, then things can be moved, of course. And we want fast code. Who wouldn't? But there are a couple of things that you should consider before blindly saying tref. Say that in my case, fun here would simply see out things. So make a little bit more visual. Say I include here IO stream, and then in fun, I'm saying that I see out the value that I received, calling this v. There's not much to move here because we are printing out the value. Chances that you really find yourself in a spot where moving makes a difference are really thin or rare. So that means whenever you're looking at a function that does not benefit from moving, it only uses or consumes the value. It's not the best idea to go with tref. And the reason for that is the following. Look below. Here I'm calling this function fun 2 times. One with the variable I, it's an integer, and the second time with simply the number 2. And if I now transform this, then we can see that we end up with 2 different template instantiations, one for intref and the other one for an R value reference. So the first one here takes an L value reference, the second one takes an R value reference, and if we now say we have another thing, a const int e, and we add this to transform once again, then we can see, oh, we cut a third one. So now we have intref, we have intref, and we have const intref. 3 instantiations for the same template for the same functionality because they all only use the parameter to print it out. There is nothing much to move. I know an integer per se is nothing movable anyway, but imagine it being a std string or something like this that could really benefit from move. It wouldn't here anyways. So the better signature for your function template is to say, let's take a const tref. That binds to temporaries and L values, and now we are down to only 1 instantiation. Okay, so this saves you code. There is a potential that the previous version gets optimized by the linker, because we did exactly the same in all cases, only the signature of the function is slightly different. You don't have to count on that. Also, instantiating templates is something the compiler has to do, and if you get from 3 down to 1 instantiation, then this saves you a little bit of compile time. Imagine it on a bigger scale, a larger project than just 17 lines of code. I'm not saying don't use tref. I'm simply saying use it when it makes sense. And if not, don't blindly say tref if you don't consume it, if you don't say std move or std forward inside your function template. This is a signal that a const tref is probably good enough. So I hope you learned something today, that you can save yourself a couple of instantiations if you don't always say tref simply because it seems simpler. That's it for today. stay tuned for the next episode. Bye bye.